Question 6. What do you call a reaction that involves the transfer of electrons from one molecule to another? So these are called redox reactions. So this involves half reactions. So the reduction half reaction and the oxidation half reaction. Okay, so let me just write the definition up here. Involve the transfer of electrons from one molecule to another. Okay, so let's have an example of how we would balance a reduction and oxidation reaction to get a net redox reaction. Okay, so for example, we had xenon trioxide plus negatively charged iodine forms xenon plus iodide. So the first step would be to balance all the atoms that are involved. And we want to separate these into their half reactions. So reduction involves the gaining of electrons, and oxidation involves losing electrons. And we can also tell if a molecule is reduced when its oxidation number decreases, and when a molecule is oxidized, then its oxidation number increases. So in the case of the xenon trifluoride, this is reduced to just xenon. Give myself some space. And we need to balance the atoms. So assuming that this reaction takes place under acidic conditions, when we need to add like oxygen, we would add molecules of water. And when we need to add like hydrogen, then we just need to add some protons. So here our reactant side has 3 oxygens and our product side has none. So to add oxygens, I'm going to add 3 waters to my product side. And now I have 6 hydrogens that are in my product side that I need to put in my reactant side. So I'm going to put my 6 protons on my reactant side. Okay, so that's the oxidation or the reduction half reaction. Now I'll do the same thing for my oxidation. So we have this negatively charged iodine that forms I2. So basically we just need to add a 2 in front to make it balanced in terms of the atoms. Okay, for step 2, now we want to balance out the charges. So we want the charges to be the same on both sides of the reaction. So let's just rewrite it down now. If we look at our reduction reaction and the reactant side, it has a charge of +6, since we have 6 positively charged protons, and on our product side, everything is neutral. So to make our reactant side neutral, we have to balance out the positive charges. So we're going to add 6 electrons to our reactant side, and the product side just stays the same. So now all the charges are balanced. And let's do the same thing with our oxidation. We have 2 negatively charged ions on our reactant side, and we just have the neutral I2. So I need to add 2 electrons to my product side. Okay, so now that we have the charges all balanced, we want to make sure we have the same number of electrons on both sides. So this is due to the law of conservation of mass. So we want our oxidation reaction to also have 6 electrons. So I'm going to multiply this whole thing by 3. So by multiplying it by 3, this changes it to 6 plus 3I2 plus 6 electrons. So now we can combine both of our oxidation and reduction reactions to write down the net redox reaction. So combining them overall, we write down all of our reactants first. Okay, so 6H plus 6 electrons plus 6 iodine makes xenon plus 3H2O. And now I can also cancel out my electrons since they are present on both sides. And then we are left with the net redox reaction. Okay, so let's see what the junior tutor said. A redox reaction is a reaction that involves the transfer of electrons between molecules. It is a combination of 2 sub-reactions, namely the oxidation and reduction reactions. During oxidation, a molecule which acts as a donor gives up an electron and becomes oxidized. On the other hand, when reduction occurs, the acceptor obviously will gain the electron that the donor loses. Yep, so this solution is correct.